Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Wafiq Syahmi bin Yaakob. So right now, I will present about our project about computer organization and architecture, about designing and engineering a computer performance benchmark using high-level tools. So I'm using the HW Info 64 tools. First, open your browser and go to the official website hwinfo.com. Then click on the download section, which is this free download. Okay, then download installer. Choose the HW Info installer version. Click on this version. Then we're gonna do download this. And then after we download this, we get this exe file. Then we open the exe files and then we click yes. Then follow the setup by clicking OK, next, accept the agreement, and then install. The software will now be installed on our laptop. Then we use sensor only, and then we gotta do start. And by clicking the sensor only, we click start to monitor the system performance. Okay, then this is the this is our laptop performance. We have assistive gaming, AMD Ryzen 5 enhanced. Okay, now we're gonna click this logging start and then save the file as workload CSV. And then this window is used to save system performance data info, a CSV file for further analysis, but for basic monitoring, we can just view the sensor directly. After that, I began workload A, which is the multi-core stress test using Maxon Cinebench. Then I opened Maxon Cinebench and selected the CPU multi-core test. And then I start logging start and then save the workload A. And then the workload A, we start within 30 minutes. And then this workload is important because it simulates heavy usage condition, allowing us to observe how the system behaves under maximum performance demand. Okay, next I proceeded with workload B. Okay, next I proceeded with the workload B, which is focused on single core performance. Again, I enable the logging in WH-Info 64 and then save the file name as workload B. Then in Cinebench, I selected the single core benchmark. In this text, in this part B, workload B, we need to test it in 10 minutes only. Okay, then we press the start button and then we continue, wait until 10 minutes. This allows us to analyze how the processor optimizes performance when fewer cores are active. Then during the test, HWI Info 64 recorded the same parameters including temperature, power consumption and clock speeds. Once the test finished, I stopped the logging again and save the data for comparisons. After both two workload A and B is done, now we can do comparison between workload A and B. First, we go to the workload A, which is represent like system operation. During the monitoring session, the CPU shows a very stable thermal performance. The average temperature is 56.6 degrees Celsius and the maximum peak temperature is 57.1 Celsius. Okay, then this is far below the maximum safe limit of 95 degrees Celsius for this processor. Additionally, both thermal throttling indicators, which are Prochot and HTC, remain at no. This means the system did not experience any overheating or performance reduction due to temperature. The cooling system is working efficiently under this condition. Next, in terms of power consumption, the CPU package power recorded a maximum 8.076 watts and an average 5.894 watt. This shows that the system was operating under a low workload and consuming very little power, which is energy efficient. Now, looking at the clock frequency, the base frequency of this processor is 3.3 GHz, while the maximum recorded frequency was 4.6 GHz. So the clock frequency increases, or delta, is about plus 1.3 GHz. This shows the processor successfully used precision boost technology to increase performance when there is enough thermal and power headroom. Now, we're moving to the workload B, which focus a single core behavior. From the data, the average active core count in 1.0 indicates only one core was actively used most of the time. This indicates a single threaded light workload. Because of this, the thermal and power values remain low and stable, with similar reading as workload A. There was also minimal thread migration since the workload did not require multiple cores. With more available headroom, the processor was able to maintain a high boost frequency of 4.6 GHz on the active core. This shows that the system prioritized higher speed or single core tasks improve performance. This is the comparison workload A and workload B, which is we can see the peak core temperature, as I said before, 57.1 Celsius for workload A and 57.1 Celsius for workload B, which is same. And this sustained average temperature, which is same too, and throttling event is no. And then the clock frequency delta megahertz is 1.3 k point 1300.1 megahertz, and for workload B is 1300.1 megahertz too. And then package power for workload A is 5.894 watt and workload B is 5.894 watt too. And then the core migration event is NA, and then workload B is 2 migration. So in conclusion, the result shows that my Ryzen 5 processor perform every efficient under light workload. It's maintained low temperature, low power consumption, and high clock speeds without any thermal throttling. However, this test only reflect light usage. A stress test would be needed to fully evaluate the system maximum performance and thermal limits. Thank you.